Welcome, everybody. Let's talk about infrastructure as code, shall we? This is a technical talk, but I should tell you now that it is a deeply personal talk. The story I'm going to tell you over the next 45 minutes is my career in a nutshell, okay? So about a year ago, I gave up my job. Okay, I totally abandoned a very comfortable role as a software development manager to start a DevOps consultancy. Now, at NewbieGo, we practice what we preach. So all our own internal software is built using a combination of CloudFormation, Terraform, Ansible. We use continuous integration religiously and continuous delivery where it's appropriate. And my co-founder is a cloud infrastructure specialist, so he's definitely more ops than dev. I'm more dev than ops. And he can be quite protective of his cloud estate, to the point where there are occasions where I need to make a change, and he will tell me something I think's common sense. So, Emma, don't forget to test your code. Okay. Emma, don't forget, no hands on the installation. It's all got to be a hands-off deployment. Okay. Emma, don't forget you've got to keep everything in source control. Okay. So when he says this to me, I have been known to utter these immortal words. Trust me, I'm a developer. I know these things. But it has become apparent to me that some of the things I think are normal and just given are a bit less mature when it comes to infrastructure as code. So my background is as a software developer. When I wrote code, I wrote Java, I wrote .NET, and then I moved into management, and for fun, I write JavaScript. Okay? And until this time last year, almost all of the DevOps engineers that I had come into contact with had sort of grown from developers, adopted more DevOps skills to become DevOps engineers. So they'd all come up through software development. But that's changed for me now. So in my current role, I lead infrastructure engineers who have never been software developers. Obviously, in a consultancy such as ours, we need to grow people from university and from colleges. These people have never known anything other than DevOps. DevOps is normal to them. Infrastructure as code isn't new or exciting to them. It's the only thing they've ever known. So from seasoned sysadmins to fresh graduates, I'm now communicating with a whole wave of developers and coders who've never written a line of Java. They've never written a single line of JavaScript, and I suspect they never want to. So these people also have not necessarily had the experience of Agile development teams, of all of the best practice that I've kind of grown up with through my career. And that's really what this talk is about. It's about the things which I thought were common sense, but which aren't quite so widely adopted in the DevOps world, and which I think probably should be. Okay? Oh. So we're going to talk about a few Agile themes. And the first one is simplicity, which the Agile Manifesto tells us is the art of doing as little as possible. We're going to talk about quality, which is my favourite subject, and I harp on a lot about quality. We're going to talk about how do we instill technical excellence into our infrastructure code. And the most important of all, how do we ensure that we as a group of infrastructure developers have a shared sense of purpose and grow a culture of shared ownership? So let's dive in straight away with simplicity. The Agile Manifesto, as I said, it uses these exact terms. The art of maximizing work not done is essential to success. And this is true. So as a Java developer, for many, many years, my team leaders would tell me that code reuse is good. If you duplicate code, that's very, very bad. And we actually have tools which help us detect code duplication, either in our IDEs or in tools such as SonarQube. These things are still maturing in the infrastructure as code world. So we have to self-check for code duplication. Okay, reusing code helps us to reduce errors. So if we copy somebody's mistakes, we're just going to keep duplicating their mistakes. So if you have to be careful, you have to self-check, right? But theoretically, if you reuse code that somebody else has built, it gives you more time and space to go and do your own research and your own experimentation and the things that you really want to be working on. And the easiest way of reducing duplication of code is to go and look for third-party libraries. So every project at NewBeGo that we have to go and build somebody's cloud estate, we build it using Terraform. And day one, the very first thing we do is to go out and look at the Terraform module registry and see if somebody's already done it before. And if they have, why don't we use that? But we know from experience that in almost all cases, we as software developers and application developers like to craft our own code. Yeah? We believe, as developers, that nobody else has solved our unique problem in quite such an elegant way as we have. So it's a hard thing to teach yourself to go and use somebody else's code and to relax some of your own rules, perhaps on quality or perhaps on code style. But if you go and use a public library, especially one which has been verified by somebody like Terraform, it means that you're probably consulting people who are experts in this area. And a good example is authentication. Most of us are not experts in authentication security. And yet, most application and systems developers will try and build it themselves. It's good practice to go and use a specialist who's built a module specifically designed to do authentication well. Okay? So it doesn't matter which infrastructure engine or which configuration management platform you're using, there's going to be a set of libraries out there that are publicly available for you to use. And at NewBeGo, if we do find ourselves building a new Terraform module, then assuming that it isn't client confidential, we upload it into our GitLab repositories and make it publicly available so that other people can use what we've built. So let me give you an example. I mean, this is text on a slide, but these are just some of the registries that we encourage our clients to use, to go and look at. At least this is a starting point. Many of them have got sample templates that you can use as your starting point. And I encourage you to go and consult them, go and make the most of the open source community around the tool that you've chosen. And even if all you do is go and read it, you'll be learning from other people the mistakes they've made, the lessons that they've gone through. Okay. I'm currently working with a client in a financial services organization where this concept is horrifying. You would never use somebody else's code because it presents a security risk. And this is true. But even if you're in a highly regulated environment, you should be able to start building your own internal registry. So if I and my team build a module for Terraform which is useful to other teams, why not make it available in our own internal private registry? Okay? Moving on. Quality. Now, I said this is my favorite topic, so I will talk lots about quality. If you would like to talk about quality in infrastructure development, let's talk afterwards. Unit testing. So unit testing is one of these things which, on software teams, people now do it with their eyes closed. It is a fact. Software developers do unit testing. And I would say it's probably 25 years since the world started to adopt unit testing in application code. I do still occasionally work with teams who don't write unit tests, which is horrifying. But on the whole, the majority of the development teams that I work with do unit testing. They have high levels of coverage. They don't even talk about it anymore. It just happens. And yet with the infrastructure teams I work with, including my own, unit testing still isn't valued. And I can't quite get my head around why. I think it's to do with the tooling. So the tooling hasn't matured, therefore the processes haven't matured. So I wanted to show you some ways in which we can test Terraform, for example. So this is a little life cycle. It's a continuous integration pipeline. Terraform itself provides you with some little tools to help you test your own code. You can use Terraform plan just to go and establish, I'm about to make these changes, do they look sensible? But Terraform plan is just the beginning. Okay, so you add in quality by layering in different types of checks. And you can do these all in an automated way. So, to start off with, we're going to talk a little bit about automated testing. So, you can argue whether or not it's unit testing or whether it's integration testing. It's kind of up to you. But I like to think of it as unit testing because it's applying a set of assertions. So we do that, if you look in the top right corner, by using Terraform apply on a sandbox. So you spin up a sandbox environment, you apply the Terraform that you're intending to in your target environment, you run a series of tests to check to see whether the system is in the expected state. Those might be server validations, they might be bash scripts, they might be Ruby files, which you'll see in a second. When you've finished running your tests, regardless of whether they passed or failed, you dispose of that sandbox environment. Okay? If the tests are passed, happy days, carry on down your pipeline. So here's an example of a really, really basic unit test for Terraform. This one's designed for running in Kitchen Terraform. Kitchen is a plugin for Kitchen CI, which if you're a Chef user, you'll probably know about. But Kitchen isn't just for Chef. You can use it to test Terraform. And Kitchen runs Ruby files using the RSpec syntax. And this one is an inspect test. It's all different terminology, but inspect is like a customization of RSpec. And this example is doing one check. So we describe controls, and I guess controls you can think of as a set of rules which must be valid for your test to pass. And inside it, you set a set of assertions, just as you would do in a unit test. So this one is running some checks on the operating system, and it's asserting that the operating system is Ubuntu. Okay? It's a really basic example, but it shows you the sorts of checks that we can do in an automated manner. One of the cool things about inspect tests is that at the end of it, they spit out a pretty JUnit type report. You can put it into Jenkins, display it with a beautiful green, that thing. I don't know what that's called. But Jenkins will display these reports in a really, really pretty manner. In our teams, where I've encouraged people to use this, actually they prefer to run it on the command line, but that might just be me. I like pretty green things. Okay, so it can get a lot more complicated than just checking the operating system, right? Here's another couple of inspect examples. So when you're writing a test for Kitchen, you can either use the inspect custom assertions, or you can use the RSpec syntax as well. It's kind of up to you. You can extend it and write your own assertions. So the top one's just checking, perhaps you've been given an image that's been pre-prepared and you want to run your hardening checks on it. This one's checking to make sure there's no passwords in stupid places. And the bottom one is checking to make sure that the expected services are running. Okay? So once again, they're simple examples, but you can see how you could use automated tests to check things such as, is the volume that's just been created by my script encrypted adequately? Or perhaps I've spun up a Kubernetes cluster, I need to check the certificate authority. You could do that in an automated manner. Okay. So yes, the tools are maturing, but the tools are there, ready for us to start using. Another great way of shifting left and spotting problems early is static code analysis. So I would say, certainly in the last couple of years, the teams I've worked with from development teams, static code analysis is another one of these things. It just happens. Most IDEs provide you with some form of static code analysis. Basically, it's about checking at the earliest possible opportunity, i.e., hopefully while you're writing the code, to see whether you've done anything silly. And I'll show you some examples. This one is, I think this one might be CFN nag, but for CloudFormation, CFN lint and CFN nag do some basic syntax checking on your file. There are plugins for most IDEs, though I don't rate them very much. Much better on the command line. CFN nag is specifically designed for security checking. So you can perform checks on your code before it goes anywhere near a source repository to check to see whether you're about to open up a security group to the world, that sort of thing. CFN NAG also allows you to write your own custom validations. Maybe you've got some specific security policies you need to implement. You can do that by customizing CFN NAG, which runs on a server in the background. TF-Lint, very similar for Terraform. This is something my teams are using, but interestingly, most of the guys on my team really use it for their local development and had never thought of integrating it into a CI pipeline. Okay. Once again, most of the tools available have got some form of basic linting or checking before you put your code into a source repository. Just one more thing on TF-Lint. It's actually fairly exciting if you use the deep setting on TF-Lint. It can go and actually check your cloud resources to do the sorts of checks which a Terraform plan just wouldn't be able to do. So things such as ensuring that if you're referencing a security profile, that it actually exists in your cloud account. Or checking to see whether the load balance you're about to create is going to fail because the name's already in use. That sort of thing. You can do that before you check the code in. So we talked about some of the automated tools that you can put into your CI pipeline. But don't underestimate the value of peer review. I do not know why, but most infrastructure engineers look at me like I am a madwoman if I propose that they code review each other's code. I do not know why. Okay? Code review is good. It's an opportunity to collaborate, and it's an opportunity to learn from others, and it's an opportunity to spot mistakes. Okay? So even if you're working with a remote team and you don't have somebody sat physically next to you checking the code, using pull requests for code reviews rather than just checking it straight in, I encourage you to try and spread the love for peer review within your teams. And if you want to take it one step further, pair programming. Why does nobody do pair programming when writing Terraform? Yeah? The more people you get to help you, the better, because otherwise you make mistakes. Yeah? The sooner we can spot the mistakes, the better. Okay. And this is erring on danger. Manual testing. It still happens, and it still will happen. And I suspect we will never move away from an element of manual testing. And with my head of development hat on, I can tell you that the most effective manual testing is done when there is a clearly defined set of acceptance criteria. Now, we often think about acceptance criteria for user stories, and there being functional acceptance criteria, but there's no reason why you can't have acceptance criteria to describe a really deeply technical piece of work. So when I'm working with development teams and I'm trying to coach them in Agile delivery, we talk about the invest principle. And this is what we use during sprint planning to try and break down big stories into small stories that are independent and negotiable. These things all make sense regardless of whether you're delivering a functional user story or a technical user story. And my favorite, obviously, is the testable one. Every piece of work that we do when we build our infrastructure should be testable. So we use the invest principle to break down our user stories, to break down our work, our backlog of things that we need to build. And quite often, certainly when I'm working with development teams, we define the acceptance criteria using the given when then notation. Traditionally, this is used for describing behavior, behavior-driven testing. You're describing a functional need. But there's no reason why it has to be restricted to a functional need. You can describe a technical need, a security need, using given when then. Okay? It helps to surface to the other people on your team what it is that needs to be achieved. And then you can run this manually if you would like to. Certainly if you've only ever got to run it once, do it manually, that's good. But you can automate given when then tests using a BDD framework. If you wanted to, you could use Cucumber. But basically most of the tools that we use when we're building infrastructure and deploying it have APIs and CLIs that you can hook these tests into. Okay? So give it a try. What's interesting is when I propose this to teams, right now, the level of appetite is like down here. Okay. What about all the time it's going to take me to write these tests? What about all the time it's going to add on to my project plan if I need to go with unit test and behavior test all of my infrastructure code? Those aren't the same, those aren't new arguments, right? When I started my career 15 years ago, I was on a team of young newbies who thought that unit testing Java code was new and exciting, and everybody told us it was a waste of time and that all the plans were going to be out because we insisted on testing our code. It's the same story now. But if you look back on 15 years of development and see how the world has changed, unit testing just is fact now, and it helps prevent errors, and it helps us go faster. So think about that investment of time. If you come across that argument, think about the investment of time in writing automated tests and how it could help you go faster in the future. Technical excellence. I have to read the official words. Okay, one of the Agile principles states that continuous attention to technical excellence in design enhances agility. And people often forget that part of the Agile Manifesto. I'm sure most of us can remember the bits of the Agile Manifesto which value working software over documentation. We can remember the bits of the Agile Manifesto which talk about comprehensive design document not being usable, and that actually, if you've got a plan, the plan's very good, but it's more important that you've got working software, right? That doesn't mean that we abandon technical design. It doesn't mean that we do not do technical design, and that's why it's specifically pulled out. Technical excellence requires us to think about what it is we're doing. So, lots of the things I've talked about already come under the banner of technical excellence. So we build in quality from day one. That's technical excellence. We perform static code analysis. We ensure that we reuse where appropriate. Technical excellence. But what else? How do we instill that excellence in what we deliver when we're building code for infrastructure? And the first one is logical separation. And it's a term which I see a lot when I'm working with teams building Java microservices. So I probably spent 6 months with one team just thinking about the design of the code. We didn't write a line of code. I know that doesn't sound very agile, but we were prototyping structures of code. And that's important because when you're designing microservices, you have to think about the flow of data through your system. You have to think about your domain context boundary, and you have to understand your data model and where there might be dependencies. And what that results in after you've thought for 6 months is a really elegantly designed set of microservices that are independent, can be quickly rebuilt if you need to, and where the dependencies between data mean that you could theoretically dispose of one. If a P1 comes along, delete it and rebuild it again. Okay? But if we're doing that for our application code, it doesn't necessarily follow that the infrastructure code will be broken down in the same way. Now, here's an example. This is the structure of the very first application we built at Nubigo. It's not a very big application. I think probably at its peak we have 2 users. But we built it, right? And this was the very, very first infrastructure project I worked on. I had never written a line of CloudFormation before we did this. But in my head, with my Java microservices hat on, I knew that we weren't going to go build one infrastructure as code file, which delivered the whole of this application. So a common approach to breaking down your infrastructure code is to layer it like this. It's not the only approach, but it is quite a common approach. So in this case, we knew that the networking needs of our application, I didn't know anything about it. I mustn't build this. So my co-founder built the networking part, built it as a CloudFormation stack. We knew that that wasn't going to change. Okay, 9 months on, it hasn't changed at all. Okay, So build it once, run it once. If we need to go and build another version of this application somewhere else, we'll just take the CloudFormation stack. Then the next layer is permissions. So once again, they don't change very often. Our applications, all of the applications that we use internally, use SAML for authentication, which means that we can build this CloudFormation stack. We can reuse it for other applications with small tweaks. Once again, it's changing on a different cycle to the networking. It's changed by a different person to the networking, so it made sense to separate them. The next one is the database, or at least the storage layer. And this one is the one which differs most and changes most depending on where we use it. So in our development environments, very, very different setup than in our production environments. So it's its own stack. It takes as inputs and parameters which tell it what type of database to use. And I'll show you that happening in a minute. And then the top one is my one. It's the one I wrote. Yay. Our application is very small. Front-end and back-end developed separately, but they're quite happily run on a single EC2 instance together. It changes quite regularly, actually. So changes to proxy settings, changes to the logging that we decide we want. At the time, when we built it, it was changing several times a day. So this, we encapsulated in one CloudFormation stack because it was changing on a different cadence. And this is where I talk about separation. Okay, we spent some time understanding the cadence of changes and logically grouped things which changed on the same cadence. And we spent some time understanding ownership. And those are the two things which might help you logically separate parts of your infrastructure code. So I talked a little bit then about injecting parameters, the most common of which is development versus production. Parameter injection and dependency management, now widely used in application development and probably not used frequently enough for infrastructure code, I don't think. The tools are there. They're a little bit basic. I expect them to mature over time. But let's have a look at some examples. So this one is CloudFormation, and I use CloudFormation because it's the one I'm most comfortable with. It's the only one that I actually write hands-on rather than lead others who use it. So this one, it takes this input a parameter which says the environment type. It means that we can use a single CloudFormation template to build whichever environment it is in our line and just change the sizes of things or change some of the security settings depending on which environment it is. And that is best practice. Where you can use one template and just take in parameters, you should do that to ensure consistency and reusability. Another way that you can do that, so think about my layered example. The application layer needed configuration, which it would read and write from the database, which meant that when you deploy it, the database has to exist, right? So we can use exports of values out of one template and pass them as input to another template. So in this case, the database layer is exporting its Dynamo ARN, and then the application layer uses that to set its own application-specific security settings on the database. Okay? It's a fairly straightforward example, but it shows you need to think about these dependencies. What are the inputs and outputs if you start to separate things out? So just in the same way that if you start to separate out your Java microservices, you need to think about what the communication between them is. If you start to separate out your infrastructure code, you need to think about what those inputs and those outputs are. And the last way that you can do that is using explicit dependency management. So in CloudFormation, there are a number of ways you can do this, but one example is the depends on attribute. So in this case, the EC2 instance depends on the database, and it will actually wait. CloudFormation will wait until it knows that the database is available before it carries on. Sorry, drink. Most tools allow you to do something like this. So Chef allows you to declare explicit dependencies between recipes. Ansible and Puppet have their own sort of equivalent of the depends on. Use it. I encourage you to go and think about the dependencies rather than run your templates into a test environment and see what breaks and then react. I encourage you to be proactive. Go and actually model those dependencies. Go and understand explicitly what thing depends on what. Maybe draw it up on a whiteboard, and you might be scared by the number of lines go here. But it's good practice to be thinking about the design of your code in advance. And when I talk about whiteboards, it really is the best way to do it. Okay? I worked with a client this year who had a whole room of design architects whose job it was to review other people's design documents. And this completely eliminated collaboration. Okay? It is good to have at least a second pair of eyes review your design for your infrastructure code. This is a good thing. But ideally, to be the most effective when you're coming up with a creative and innovative and effective design, get into a room, use a whiteboard, and draw it, use sticky notes. Okay? We value people and processes over tools and official stage gates. So that leads me on nicely, when we talk about collaboration, to my final theme, which is about, I think, the foundation of Agile software delivery. And that is having a strong direction, a strong sense of purpose that brings everybody together. So, the first one is the product owner, and I was talking about this with some people over dinner last night. Is there a role for a product owner in infrastructure? Absolutely yes. So a technical product owner is a hard person to find. There are not many people on this planet who are able to communicate real business value into a set of infrastructure needs. But it is possible, these people do exist. And when you find them, what they do is to help understand your end user needs. It's that empathy piece that Jeff was talking about. Go and really understand what the need is, and then help translate it into a set of tasks that need to be done to deliver on that promise. Okay, so a product owner. The one way that you can go and make use of a product owner is to embed people into existing delivery teams. A traditional product owner is quite function-based, functionality-based. You can make use of them and their skills, but what I see tend to happen on teams which aren't quite yet mature enough is that the product owner doesn't necessarily value the infrastructure needs and will quite often prioritize the functional needs over the infrastructure. So it does demand quite a mature team to be able to mix dev and ops in one team. So, talking about cross-functional teams, we've all heard of I-shaped people and T-shaped people, I think. I feel like I've spent the last 10 years of my job recruiting for full-stack developers. And in my head, a full-stack developer is T-shaped. They are a specialist in one area. Perhaps they might be a specialist in Node.js, or they might be a specialist in front-end development. But they've got this broad T banner, which means that they can apply themselves to anything on their team. And maybe you're getting towards the end of a sprint, somebody can jump on and help out with the piece that they're not really a specialist in, but they get the job done. But like I said, over the last couple of years, I saw my role change to be more DevOps, and the role of the engineers that I was employing to be much more DevOps. So my expectations on a full-stack developer had changed. And my husband described it as cone-shaped, and I don't know whether you agree. But a cone-shaped engineer is a specialist. They're a specialist in DevOps tooling. But if you're going to use the label DevOps engineer, what is your technology speciality? What is it that you are good at? You're good at everything, right? You can't not be good at continuous integration. Maybe you're a Jenkins engineer, but you also have to know and understand containers. You also have to be able to know and understand how to write scripts. You also have to be able to manage a Kubernetes cluster. And you can't just do a little bit of each of those things. You have to be reasonably talented at all of those things. So I describe that as a cone-shaped engineer, and you don't need a whole team of them. But if you're going to build a cross-functional team and you need people who can get the job over the line, and you have access to a couple of cone-shaped people, you're more likely to succeed. And this is my final theme. Cross-functional teams I can tell you from having been a development manager now on maybe 5 large transformation projects that a cross-functional team will always be the one who appear to be the most successful. A team only works if everybody has a clear direction, so a strong product owner who can deliver on a vision to work towards, where the team trust each other to make mistakes, to correct them, and to pull you over the line. Okay? So while that doesn't necessarily tie to technical excellence or quality, it's the thing which brings it all together. We succeed together. We work together every day. We do awesome stuff together. So you have to trust each other. And that brings me to the end of my talk. Now is the time for questions. Anybody got questions on the technical or the non-technical bits of what we talked about? Does anybody actually unit test their infrastructure code in this room? Like 3 people. Okay. So that's really interesting. In London, it was a much higher percentage of the audience. And the excuses that I hear, like I said, are the ones around investment of time. And think of it that way. It is an investment. You may have to wait to reap the benefits. Okay. Any other questions? No? In which case, I'm going to lurk down here if you want to talk. Hello? Okay, so the question is, how important do I feel it is to have a shared and aligned set of processes and tools in a larger organization? Okay, so I'm working on a project like this at present. I personally would encourage independence of teams. So to provide a really overarching set of guidelines which do not dictate official detailed process or do not dictate tools unless there is a very strong regulatory or financial reason to do so. So to give the teams freedom to experiment. So if you choose a tool for the whole organization now and force people to use it, it reduces their capacity to innovate and to experiment and to learn from mistakes. So while that is my advice, I understand it's not necessarily appropriate or achievable in some organizations. Okay, nobody has any other questions. I'm going to lurk down here. You want one more? How do you keep your unit test? Okay. Okay, so the question is, how do you keep your unit tests fast? And you quite rightly pointed out that the sorts of tests that we saw tend to be slower than application unit tests because they're doing a lot more than executing 2 lines of code in something which is already pre-compiled. Okay, so just based on my experience working on teams who've had millions and millions of Java unit tests, for instance, and then maybe 100 integration tests on the top of it, is that you have to reflect regularly on the value of those tests. So if your build cycle and your integration cycle is taking more than 15 minutes, people tend to lose interest. Try and keep it within that 15-minute timescale. I understand people quite often will run a full regression or a full automated test suite overnight. But if you can keep your tests focused and isolated in 15 minutes, people will engage with the process. And you can only do that by regularly reflecting on the value of those tests. So maybe today, I write a set of tests which check to see if the operating system is Ubuntu, because those are the sorts of common mistakes being made. But 3 months from now, things have changed. People have matured. Nobody's ever making the Ubuntu mistake again. they're making different mistakes. So get rid of the tests which are taking time and focus on the tests which are offering value now. And that actually, where we talked about processes, the client that I'm working with to define their overarching processes, one of the processes is to ensure that they've got a regular review of their tests booked in. And that might just be half an hour, once every 2 months. Are the tests still offering me value? Does that answer your question? Mm-hmm. Remove it. Yes, so that's what I advocate for. Have a sandbox environment which is representative of your current production state. Apply everything you intend to apply when you upgrade, whether that's 2 hours worth of work or 2 weeks. Apply it and then check that you understand the state of the system. Is it as you expect it to be? But to keep those checks lightweight and focused on the most valuable and the most risky things. So you can use a risk-based assessment. How likely is it to go wrong? How likely is somebody to have got the operating system wrong? Low. And what will be the impact if it is wrong? And choose those as your regular short tests. Okay, thank you very much for your time. Hope you enjoyed it. Come chat to me during the day if you want to find out more.